Hello everybody, it's Mr. Ray again with our next lesson in calculus. We're going to continue our adventure into the slope of a tangent, and this is the basis for the part of calculus that we're going to be uh, doing for the rest of the semester. So uh, a lot of this is seems like it's a lot of work, but what we're going to do today is just try to develop kind of a more streamlined model for finding the slope of a tangent of any function. And we're going to look at three examples of some slightly more complicated functions compared to what we started with in the previous lesson. On the regular course, this would be Unit 5, Lesson 3, which is Slope of the Tangent Part 2. It's just continuation of what we did in the previous lesson. Okay, so the definitions here, secant, tangent, conjugate, they should be meaningful at this point. If they're not, just reread the definition. Now, in terms of the concepts, just to reiterate kind of what we've been doing, when we talked about the slope of a tangent, remember tangent touches the curve at one point. We want to get the slope of that tangent. So the way we did that was we kind of simulated this point Q. If we wanted the slope at point P, we had this other point Q, which kind of slid along the curve closer and closer to P. So basically, PQ would be a secant because it's really touching the curve at P and Q. So as that gets closer and closer, it basically merges into a tangent as the distance between those points approaches zero. So the way we did that was with a limit. You're going to see a lot of that in the next few weeks. The limit as the change in the x value approaches zero of the slope of that tangent. Now this is what we're going to be looking at today. It's basically the limit as h approaches zero, where h is the distance between P and Q. Of this on the top here, this is basically rise over run, so this is the change in the y value over the change in the x value. So f of a plus h, that's basically the y value of point Q, and this f of a is the y value at point P, which we're now going to be referring to a as the x coordinate of that point P. Okay, so we have a, which is the actual x value of P, and h is that difference between P and Q, but it's going to approach zero over time. So in order to, this is a nice little a model here, process. In order to find the slope of the tangent at point P, that has x coordinate a, and the y coordinate would be f of a. First thing we do is we find the value of f of a, and that might just be it might not be a number. It might be an expression with a variable, and that's fine. Then we do the same thing with f of a plus h. That's basically your y coordinate of your q value. And then we plug these two values into this formula here, f of a plus h minus f of a. That's the rise, and the change in the x value, the run, would be, this is always going to be h, which we'll start doing from now on, because it's really a plus h minus a, but the a's cancel out, so you've just got h. So that's why that's always h on the bottom. It's because it's the change in the x values. The change in the x values is the value of h. Okay, so this just reiterates what we did up here. So let's dive into an example. We got three of them today. So this time we want to find the slope of a tangent. We have a polynomial here, f of x, negative x squared plus 4x plus 1, and we want to find the slope of that tangent at where x equals 3. So basically this would be your p value. So the x coordinate would be 3, and we're not sure what the y coordinate is. In order to get that, I'm going to do this little sidebar calculation here. Let's get what is the value of f of 3, because we do need that. That's the y coordinate of P, and we we actually need that in the formula. So this is just plugging in your x value, so that's negative 3 squared plus 4 times 3 plus 1, and that means, so that's negative 9 plus 12 plus 1, that's going to be 4. Okay, so that we can plug that in. That's your basically your y coordinate of the point where you want to find the slope of the tangent. Okay, the other thing we need, if you look back here, is we just did this. That was f of 3 because they told us the a value or the x value we want is 3. Now we're going to do f of a plus h. In our case, that would be f of 3 plus h. Now, obviously, this is not going to be a number when you plug it in, and it is a little bit clunky. It's just a lot of math to plug in. So wherever we go back to our f of x function and we plug in f of 3 plus h. So wherever we see an x, we change that to 3 plus h. So there's our negative x squared, changes to that, and then we have plus 4, 3 plus h, and then plus 1. So basically we just substituted in 3 plus h. Now, when we do the squaring, don't forget that's binomial squared, so it's going to be, I'll put this in brackets, it's going to be 9 plus 6h plus h squared, but it's all negative. And then we have our 12 plus 4h plus 1. Now, each of these terms flips the sign to negative. So if I simplify that, I've got negative h squared, nothing over here. I've got a negative 6h plus a 4h, that's negative 2h. And I've got negative 9 plus 12 plus 1, so that's a plus 4. So this is our f of 3 plus h. So these are the two values we plug in. So I'm going to go back to here, and our formula is always going to be the slope of the tangent, or m tan you could put, is the limit as h approaches 0 of f of 3 plus h minus f of 3 over h. Okay, and we've just already done these calculations for f of 3 plus h and f of 3, so we plug them in. Don't forget, I mentioned last lesson, it's easy to forget to put this in each line, and I know it's a bit of a pain, but it has to be there because you're going to use it near the end. Okay, so f of 3 plus h, we basically plug in what we did here, minus 2h plus 4 minus 4. So I did this minus this. Now you can see that the 4's cancel out. So there's different ways of doing this. I could just see, oh, there's an h in each of the remaining terms, so I divide out the h and I get my answer. Or you could, you could factor the h out on the top and then show that you're canceling the h's. Whichever way you prefer that makes sense to you. So for me, I'm just going to, well, let's do it with a canceling just to show you what I mean. If I factor out an h here, I get a negative h minus 2 over h. So just those disappeared, factor an h out, and now you can quite easily see those cancel. Those are h's, by the way. And then I get limit as h approaches 0 of negative h minus 2. Now, up to this point, you couldn't plug in h equals 0 because the h being on the bottom was a problem. That caused a divide by 0 error. But now that we've canceled that h on the bottom, and that's always going to be our goal, it will always work if you do the right technique. Now we can safely plug in h being 0. So when we do that, we get the slope is equal to, if that's a 0, then the slope is negative 2. Okay, so what that tells you is the slope of the curve, the polynomial f of x at x equals 3 is -2. Okay, and we could get the equation of that tangent if we wanted to. We did this in the last lesson. We just make a line y equals -2x plus b, and then we plug in the only point we know that's on the tangent. Remember, it has to be on the tangent, just not it. Plug that in, and we get the actual equation of the tangent. Okay. All right. Hopefully that makes sense. Now we'll move on to this one. So that's a trinomial. Sorry, that's a trinomial here. Let's try a reciprocal function, a rational function. This is a little more complicated. 3x plus 6 over x is our function, and we're going to evaluate that slope at the point 2,6. Now they didn't have to give us this 6. They could have just said at x equals 2, and we could have just plugged in 2 into f of x or f of 2 to get the value 6. So that just saves us the calculation. Okay, so in this case I'm going to start off like we always do. Slope m is equal to the limit as h approaches 0 of, so this time, so h on the bottom, get that done. I'll just put it in function notation, so it's going to be f, and that's our a value, so f of 2 plus h. So that's like our imaginary point q as it slides along, and h gets closer and closer to 0. Minus f of 2, and that's the point where we actually want to calculate the slope. Okay, now this one's a little more complicated because of the reciprocal. So I'm going to, instead of doing the calculation over on the side, you could do that, and it's probably a better idea, because what we're going to end up here is kind of a, like a fraction and a fraction, like a double rational expression here. So if I do f of 2 plus h, that's basically, this is going to be my f of 2 plus h, and I'm going to subtract f of 2. Now f of 2, we already know what that is, so let's just get that out of the way. F of 2 is 6. So I'm just going to say, I'm going to figure out what f of 2 plus h is here and subtract 6, because that's f of 2. So when I plug 2 plus h into here, I get 3, and then the 2 plus h goes in the brackets, plus 6 over x. So remember x, that's our 2 plus h. So we have 2 plus h on the bottom, over h. Okay, now this is a little bit tricky, because we're going to have to, first of all, we're going to simplify this, and then we're going to turn this into an equivalent fraction or rational expression, so that we can combine these two. So let's first simplify. So we get 6 plus 3h plus 6. If you see that there, we get a 6, we get a 3h, and we get a 6. So that turns into 12 plus 3h. So 3. So 12 plus 3h over 2 plus h. Okay, now the 6 here, let's change that now. We want that to be over 2 plus h, so that's basically, we'd have to, this is like 6 over 1, so we multiply by 2 plus h top and bottom. So when we multiply the 6, which is on the top, by 2 plus h, we get 12 plus 6h. And again, it's all over h. So now you can see we've got a rational expression. We can combine them now, so let's do that. So we got 2 plus h on the bottom of the numerator. We got an h on the bottom. Okay, so we basically subtracting, so be careful. So we have 12 minus 12, they cancel out. We have 3h minus 6h, so that's negative 3h. Okay, so that, that's not too bad to work with at this point. So I'm just going to write this h as h over 1, just to make it obviously. So remember, whenever we have fraction divided by fraction, we can just change it into multiplying by the reciprocal. So limit as h approaches 0 of, I'm going to put this in brackets, negative 3h over 2 plus h multiplied by 1 over h. Okay, and you can see when we do it this way, we can see, well, the h, that h will cancel with that h, leaving the 3. So we have limit as h approaches 0. What we have left is a negative 3 on the top and a 2 plus h on the bottom. Sorry, yeah, a negative 3 over 2 plus h. And although we didn't totally get rid of the h on the bottom here, we did change it so that it's, h plus 2 or 2 plus h, so that when we plug in the 0 at this point, the denominator is not 0, so we don't have the divide by 0. So we can safely actually plug in the 0, and we get the value negative 3 over 2. So that is the slope of the tangent of this reciprocal function, a rational function, at the point x equals 2, the slope is negative 3/2. Okay, so that was a trickier one, but we just did the math and tried to simplify as much as we could, and we ended up getting to a place where we could safely plug in a 0 for h and get an actual number. Okay, so let's do one more example, and this time we're going to do a square root function. So find the slope of the tangent to f of x equals square root of x at the point determined by x equals 9. And you could very easily plug in x equals 9 and you'll get f of 9 is the square root of 9, which is 3. Okay, so you could say, well, we know the point where we're finding the slope is the 0.93. You can call that p if you'd like. Okay, so let's set this up the way we have been. So the slope that we're interested in is the limit as h approaches 0 of, and here's our generic, f of x plus h minus f of x over h. Okay, limit as h approaches 0. So f of x plus h is just plugging in x plus h under the square root, so that f of x plus h is the square root of x plus h, and subtract f of x in this case, that's our f of 9, so that's actually equal to 3, and that's over h. So you may look at that and go, I don't have a clue what to do, and but if you remember our first video lesson, actually the first lesson, we talked about not only rationalizing the denominator, but rationalizing the numerator. And that's what we're going to do here. We're actually going to multiply this whole expression by the conjugate of the numerator and see what happens, and hopefully something good comes out. So if we write it x plus h square root minus 3 over h, and what we're going to do is, don't need all these brackets, but I like brackets. So we're going to multiply that by the conjugate of the numerator. Sorry, I should have been putting, instead of the x, I should be putting 9, because that's the value of x. So that's 9 plus h, 9 plus h. Okay, that's better. So the conjugate of this, remember, it doesn't exactly look like a binomial, but let's just consider this as the first term. Okay, this is the first term, this is the second. So if looking at it from that perspective, the conjugate would be square root of 9 plus h, and then we just change the sign here, plus 3. Same thing on the bottom. Okay, so let's see what happens here. Okay, now when you're multiplying these two together, I want you to think more in terms of this is a difference of squares. This is like a minus b, a plus b. So remember, anytime you multiply a difference, these two factors, it's going to be this term squared minus this term squared. So when we square a square root of 9 plus h, we just get 9 plus h. So that's like our a squared. And then our minus b squared would be subtract 3 squared, which would be subtract 9. Okay, so that worked out pretty nicely. And then we've got our h. I'm not going to bother distributing this, and you'll see why in a second. I'm just going to leave it undistributed. But what you're going to see here is these 9s, plus and minus 9, cancel each other out. I might as well show the step here, and then you can see I'm just left with an h on the top. And you can probably see I've got the h on the bottom as a factor. So at this point you can cancel those two out. Don't forget you're left with a 1 on the top. So it's 1 over square root of 9 plus h plus 3. And if you now try to plug in, see up to this point, if we plugged in a h equals 0, we get 0 on the bottom. But now if we plug in h equals 0 here, we're going to get a square root of 9, which is 3, plus 3, we're going to get 1/6. And that worked out quite nicely from something that looked like we had no idea what to do. So the secret here was multiply, basically rationalize the numerator by multiplying by the conjugate of the numerator. Okay, so hopefully that gives you some more examples of how to find the slope of a tangent of any function. I mean, we've looked at a few now. We've looked at polynomials, rational functions, and radical functions. So we've got some examples for you to work on. Make sure you know how to do this yourself. Some of them are trickier than the examples, so you think your way through it. I've also got the solutions posted, so give it a try. Make sure you are able to do this, okay? And don't forget we have our weekly math help sessions that you can call into on Tuesdays and Thursdays. So if you're getting stuck, you're not sure what to do, just log into the call and we can go through some questions together. Okay, thanks. Have a good day.